Yo, check, check. All right, welcome to week 35 of Chill Kernel Hacking for Fun. This will be a good one. I'm getting back into things because I was away for a few weeks, and I had these pre-recorded sessions. So today we're going to be getting back into the flow of kernel hacking here. Eventually, I do want to get back into Lab 4, which is what we were working on last time. The whole goal there was to get symmetric multiprocessing working with the OS to basically allow the OS to use different, multiple CPU cores basically, and kind of graduate the OS from a single core operating system to multi-core operating system. And this is where we left off last time. So I successfully got a bunch of CPUs running. I was actually kind of getting back into this, and I kind of forgot a little bit of the state I left it off in. But here was the last commit we had. And if I just run the kernel, so that was only one CPU. This assertion is actually pretty concerning. I don't really understand it. I don't know if that's what I was seeing, or if that's the state I left the code in intentionally, but let me just do a quick run of like CPUs 8. I'm also gonna test, do a test thing in the chat to see if that's working. So now I ran the OS with 8 CPUs, and we can see that they're all starting up. I still have no clue what's actually happening here though with this assertion on the interrupt flag. So truly have no idea what's going on there. That might be bad, but I believe that's where we left off. Let me get my Miro board ready, just in case we'll need to make some visualizations, which we often do. I think, oh, here is about where we were, somewhere around there. Yeah. Maybe it would be helpful to do a quick recap of what's going on. So I've been working on this operating system, basically, and what I mean by that is I've been following this MIT course, and we spent a long time on Lab 3 to get user environments running, which are basically processes, which involved getting interrupts working, getting exception handling working, getting basic system call support working through interrupts. And I remember getting to here, exercise 10. Can you show the link? Yeah, what's up, Rajan? Yeah, for sure. I kind of just want to go back and test this to make sure I'm kind of going from a sane state, since it's been a few weeks from where can I get started. I mean, just follow the coursework. Like, the coursework is pretty thorough and kind of guides you through what you need to get started, including downloading the code and stuff like that. So yeah, it's relatively straightforward. You can join the Discord if you want, and we can help you further there if you have questions. There are a couple of tricky bits. Yeah. So here's what I want to do. I just want to briefly kind of come back here And hey, what's up, Jimothy? Thank you very much. I'm just getting my brain out of vacation mode and just trying to figure out what's going on. What I kind of wanted just to confirm was, so this thing should have been still in a correct state. Let me fix lab4 boot bug. I don't want to spend too much time just debugging this, but I'm kind of worried about that assertion. So I'm also worried about this assertion. Yo, Lizard, what's up, my guy? Long time no see. Hope you're doing well, dude. Man, this is crazy. Initial user map check. Merge error. I'm going to check back all the way back to lab 3. Oh, what? Okay. So this looked kind of right to me. What is that running divide error? Because maybe div 0 is the one, right? That looks pretty good. So today, right now, I'm just like kind of getting back into things after being away for a couple weeks. But what we're doing today is actually scheduling. So the state I kind of left things off before I went on vacation was we actually got like basic support for booting up multiple processors. And the goal is to use that and eventually get tasks and processes running and executing on all of the CPU cores. That's kind of the next step. Specifically exercise, I think I already did exercise 5, and we're gonna get going with round robin scheduling. I think we'll just do that. I think we'll just get going with that. I was just trying to, I got kind of confused because I was seeing a bunch of assertions that I don't recognize. Maybe I think the best thing is just to keep going. So here's what happened. Basically, I finished lab 3. That's what we're kind of seeing in this Git history. Did all of this work on lab 3, and that brought us to the end of lab 3. Basically, like this. And then I tried going to lab 4. So I graduated and started lab 4, and this required merging my lab 3 branch into the lab 4 branch, which has all the lab 4 code for multiprocessor support. And that wasn't like easy. So I think the first thing was like, there was like some merge conflict error that I needed to fix. And then I encountered this really bad boot bug. And that's what my stream from last week was about. Week 34 was about debugging this really bad boot bug that it was like this really strange bug that was like a side effect of merging in the lab 4 code, which had a bunch of like side effects on the kernel because it introduced these big global buffers basically, which caused a bunch of crazy stuff to happen and broke the boot process. But I fixed that, and then I started on the lab 4 stuff with this MMIO map region thing. Yeah, so that was exercise 1. So we're kind of seeing me start exercise 1 here. But the code is kind of messy. You know what, I might take the opportunity to do some cleanup stuff. So I'm going to fix this up into the previous commit. So now I think that should actually be working a little bit better. Actually, wait, no, I think I did not mean to do that. Oops. So this is, hey Galing. This is actually, this is exercise 2. So I'm just going to, exercise 2. Wow, so hard to see. And, oops, shit. From being allocated. This will be used for bringing up the APs. Okay. So it's 1, exercise 2. And then this one, map multiple kernel stacks. That was exercise 3. This is exercise 4. And that's exercise 5. You know what, let's just YOLO it. I don't know what those assertions were, but let's pretend like they didn't exist. So current state of the art for my kernel is 4. Right. Current state of the art is something like this. I can run the kernel with 8 CPUs, and we get all these messages about things booting up, starting up. I don't understand that assertion. Hopefully, I mean, that, my guess is that is going to come back to bite me in a major way, but I don't really know why it's happening. Just to quickly take a look, that's asserting on this trap frame. Just curious though, what did it say? You can't test if your locking is correct. Yeah. All right, whatever. So to review exercise 5, basically we're trying to make this journey towards having the kernel run on multiple CPUs, but unfortunately the kernel at this point isn't thread safe because we were only ever running, like, it just didn't need to be. But now it kind of needs to be because we're starting to run on multiple cores, which means different cores can be running code in the kernel at the same time. And the simplest way to fix, like, make this work, because without any effort, like without any like action, if we just try to run a kernel on multiple cores, we'll have all these data races and race conditions, and so that'll make the kernel not work. And so the easiest way to fix this is just to add a huge lock everywhere. which it describes here. And we're going to just have this big spin lock called the kernel lock. And it is, it's just going to take these very aggressive locks. And so, as it says, on the main init, the main processor takes the lock before it wakes up the other CPUs. And np main, that's the main function that runs, on the np main. np main. This is the function that runs on all of the application processors, which are like the secondary CPUs. And after they do their initialization, they try to get the lock before going into the scheduler. And trap acquired the lock when trapped from user mode. Let's make sure I did this right. That's what I attempted to do here. Yo, going, how did you get into kernel development and work full-time there? So, to be clear, I don't work in kernel development. This is just a hobby thing for me. And I got into it by starting to stream it like 6 months ago. Nothing like really too special. I used to work in information security though, and had a bit of experience with low-level programming before this then. So acquire the lock when trapped from user mode. So this runs whenever there's like a trap, like an interrupt or exception that needs to be handled, and we can inspect the trap frame to learn more about the cause of the interrupt or exception. And in particular, we can look at the code segment register, the low bits of the code segment register, to identify the privilege level of the code that was running at the time of the trap or interrupt. And if it's ring 3 or privilege level 3, that means it's users mode. And so it says, yeah, acquire the lock when trapped from user mode. In env release the lock right before switching to user mode. Env run is the function that basically drops into user space from kernel space. Starts executing code in user space. And that's what I did here. I added this unlock kernel as we're about to leave kernel space, because the lock needs to be held for pretty much the entire duration that we're executing in kernel mode. Shellfish. Yeah, I am not a current member of Shellfish. I previously have played with Shellfish in a couple CTFs, but these days I'm just a fan and cheering from the sidelines. But good eye. So let's just read through this rest. So it seems like the big kernel lock guarantees that only one CPU can run kernel code at a time. Why do we still need separate kernel stacks for each CPU? Describe a scenario in which using a shared kernel stack will go wrong, even with the protection of the big kernel lock. So the intuition behind this question is like, okay, if only, I mean, yeah, as it says, if only one CPU can be running in the kernel at a given time, why can't we just have like one kernel stack then that just gets used by each core one at a time? And I'm pretty sure the problem here is with actual interrupts, like hardware interrupts, because we might be running on one CPU core in the kernel, processing a system call or something like that. But then on another CPU core, we might get an interrupt of some kind that needs to be handled. And when that happens, the CPU is going to push a bunch of stuff onto the kernel stack. And we don't want to just do that on the main stack that's executing on some other CPU. We don't want them to interfere with each other. We need a separate space for each CPU to handle exceptions independently of the other ones. At least that's my understanding here. The big kernel lock is simple and easy to use. Nevertheless, it eliminates all concurrency in kernel mode, which kind of basically defeats the point of supporting multi-core. Partially. I mean, it's useful to have, even with the big kernel lock, it's helpful to run user space programs in parallel. Like, that's valuable, but it's a major limitation to have the kernel basically be single core again, or basically have no concurrency. So then it's saying, okay, so now we can do better. We can use different locks to protect different portions of the shared state. Fine-grained locking can improve performance, but it's just like harder to code. If you're brave enough, drop the kernel lock and embrace concurrency. Up to you to decide the locking granularity. As a hint, you may consider use spin locks to ensure exclusive access to these shared components of the kernel. Page allocator, console driver, scheduler. Interesting. For the moment, I'm definitely not brave enough to do that. I am super scared of everything here, so I'm going to keep things as simple as possible for myself. But let's move on. I watched a few of your streams and pretty good at explaining things. Thank you. Are you going to make a tutorial playlist on kernel development for beginners? I don't have any plans for that currently, because to be honest, there are other people that have done that already and they're pretty good. Like Nanobyte has a very good YouTube channel for that kind of thing. I would be open to it, but I don't have current plans for it, but thanks for asking. Okay. Your next task. Okay, I'm still kind of bothered by the fact that I don't understand why this assertion is happening. And I don't know if I should spend a bit of time to just figure that out and like debug it a little bit, because I kind of don't know what's happening with the kernel right now. I believe that, so right now, so this exchange is what communicates to the main CPU. Let me bring up both these maybe. So at a high level, what happens with this multi-processor boot up thing, excuse me, so it's like, here's i386 init. It's like the normal boot sequence for the main processor. It's doing all its normal like single core, just like initialization. And then it hits MP init, which is where it, by the way, I didn't write a lot of this code. A lot of this code came, I didn't write any of this code. It all came with the JOS OS from the course. Basically, this code kind of like interrogates the system to determine how many CPUs are on the system, and then we're going to use that, or then we're going to use that. Interesting. I actually don't know what this is. MP init. Okay. We're going to use that here, I believe. Oh wait, no, we're gonna, okay. Yeah, clearly I don't actually understand this very well. So MP init, then waypick init. and pick init. Okay, this is all stuff I don't understand, but what I was looking through last time is the boot APs. This is the thing that actually goes through all the CPUs one by one and starts them up. And this is a serial process. One by one, we just go through each CPU and send like some boot up, send like a boot up sequence or like interrupt technically to it. And we literally block in the main kernel, in the main core, until the other CPU indicates that it has started up. And the way it does this is right here. It atomically swaps in this CPU started state. And then theoretically it should just block, which I believe it does because the main kernel the main core has locked the kernel. So that should all block, and I think that's what we see here. Then new env load icode. Question is, you know, what I'm gonna do just to kind of debug this a little bit. Is I'm actually going to make, or where's MP main? I'm going to just like hard spin all of these CPU cores while I just quickly figure out what the main core is doing here. Okay, so that guarantees that these things are actually not running anything. So now I'm going to go back to i386 init, and I'm going to here's user primes. Let me just like user div 0. I wonder, I don't actually know what primes is doing. Holy crap, what IPC? Jesus, okay. That's such an advanced program. Fork, oh man. I'm gonna go back to my friendly div 0 safe div 0 program, which just does a divide by 0 and run the kernel. And hopefully I'll see something that's okay, interesting. It still continues to do this with the interrupt flag. Yeah, I have no idea what's going on there. So line 202. Check that interrupts are disabled. Yo, what's up, Aravind? Hello. Do not be tempted to fix this by inserting a CLI in the interrupt path. Hey, Ayla. Yeah, I kind of have multi-core working a little bit. And now I'm kind of looking into this assertion with the interrupt flag thing, which is totally unfamiliar to me. And I don't know. was it something that got introduced in the merge process, maybe? I just think this is kind of bad. Like, I think this is actually bad enough to debug it right now, because I don't know if I'll be able to continue with these exercises if I don't have that working. What? Because, so like, what actually changed? Here is the merge. Here's the diff of what I added to the lab 4 code. It's basically just all of my code from lab 3, right? Basically. Sheesh, okay. Kernel panic. So what I'm going to do is I'm going to do my classic strategy of breaking. Oh shit. I'll try to run that. I'm going to try to break here. I want to debug it. Such a bummer. GDB, CPU. Or I'm just going to, like, what happens if I run it without multiple CPUs? It should still do that probably, right? Okay. So I'm just going to debug it, GDB, make GDB. Oh, we didn't even ever get there. Okay. Maybe it's this weird sketch yield thing, actually. Oh, maybe it's the timer interrupt, something like that. Okay, this might not be a bug in my code, then this might just be a normal part of doing the labs. How's my working tree doing? I see, because now we're jumping into all this sketch yield stuff, which I don't understand. And create, though. I just, just to refresh, how did entering user space and run, right? That's what we did. That's what happened last time. So I'm just going to try this back over here. So now I'm going to go here, and instead of doing sketch yield, I'm going to do div 0. And I'm hoping this will look a little bit saner. Okay. Holy crap, Creamu just crashed. What? Oh my gosh. Is that for real? Did I just crash Creamu? Holy crap, Creamu just crashed. What the oh man. Okay. All I was trying to do there was just kind of get this to work again. Just do that super basic thing that we were doing in the lab 3 code that caused the div 0 program to execute correctly. That's crashing Kimu. Crazy. Assertion failed. It causes an assertion to fail in Kimu. IO thread locked. What the hell? You know what, I'm just gonna ignore all of this and just power through as if this is all good. I'm just gonna ignore all these things and proceed with lab 6 and just see what happens. Okay. Your next task in this lab. Also, my break timer is running out. Or start with the break timer. Alright, quick. I'm gonna check my camera quickly. I think I'm using my phone for my camera. I think it's running out of batteries. I'll be right back. Let's take a 20-second break. Jump scare. You mean the Kimu crash? What is going on? Wait, didn't? Oh wait, but it did. Okay, it didn't crash because I changed the code. Okay, but if I go back and just put this thing in, I don't even. What was it? End run ends 0. Dude, what the hell? I'm just trying to have some fun on my Sunday, and Kimu's crashing on me. Okay, yeah, we're not doing that. Did you input ATA? Nope. What is ATA? Disk? Something with disks, I guess? Okay. I have no idea. Yeah, it's maybe for later. Okay. Change the JAWS kernel so that it can alternate between multiple environments in a round-robin fashion. Round-robin scheduling works as follows. The function scheduled is responsible for selecting a new environment to run. You know what? Before I move on, I'm going to take a screenshot of this, save it in the old Miro with a note, because this is kind of interesting. To replace the scheduled, and it causes this crash even with just one CPU. Okay, let's get into it. So scheduled is responsible for selecting a new environment to run. It searches sequentially through the ends array in circular fashion, starting just after the previously running environment, or at the beginning of the array if there was none, picks the first it finds that is runnable, and calls env_run to jump into it. Scheduled must never run the same environment on 2 CPUs at the same time. Interesting. I don't immediately, I guess. Okay, so an environment, well, it's kind of like a thread, I suppose. I mean, it's a little bit unclear to me if the environment is more like a process or like a thread, but I'm just going to assume it's more like a thread at the moment. So yeah, a thread should only ever run on one CPU at a time. Our process can have different threads that are running on different CPUs at the same time, but a single thread only ever executes on one CPU at a time. We've implemented a new system call, sysyield, which user environments can call to invoke the kernel's schedyield function. Yo, Jax, I am doing lab 4 in the MIT class. Got multi-core support boot running, and now we're working on getting scheduling working. Okay, kernel's schedule function. Yeah, okay. So exercise 6. Implement round-robin scheduling as described above. Don't forget to modify syscall to dispatch sysyield. Make sure to invoke scheduled in MP main. Modify kernel init.c to create 3 or more environments that all run the user program user /. Okay, this is already bad because I'm having this assertion with the interrupt flag which I don't understand. So I think that might mess me up as I try to do this, but All right, give me 1 second, guys. My phone is running out of battery. I need to change it out for the camera. So give me 1 second. Let me change out my camera because it's running out of batteries. Be right back. Still here, just changing out the camera. My camera just disappeared. Yeah, 1 second. Okay, let me try switching back to the other camera. Doesn't look like it. Sheesh. You know what? I think I'm gonna. Wait a sec. All right. You know what? It's is monitor camera it is. 1 second. Yeah. All right, let's fix this camera angle. Okay. Sorry about that. It's been a minute since I used this camera angle. All right, let's get back into it. So, scheduled as described above. Let's check this thing out. Let's also delete. I'll get all these tabs out of here. Should.c. scheduled. Okay. Implement round robin scheduling. Search through envs for an env runnable environment in circular fashion, starting just after the end of the CPU was last running. Switch to the first such environment found. If non-runnable, but the environment previously running on the CPU is still env running, it's okay to choose that environment. Never choose an environment that's currently running on another CPU. If there are no runnable environments, simply drop through to the code below to halt the CPU. Okay. So I need a moment to remember everything here. So we have this envs array. And free list. And I need a envs is created somewhere here. I need to find my old illustration of this whole thing. Okay, I'm getting a bit confused because I just don't understand the data structures here anymore. I kind of forgot how they work. So we have the end free list, which has all of the possible environments, but not all of those are, well, those are actually the ones that are not in use. And insert them into the free list. What I'm really not understanding or remembering is what envs actually is. So let me go back and find out how this thing is used. It's this env create, I think it's like this env create thing. Hey Kai, really excited to see as a newbie. Can you really do it? Can I really do it? I don't know. I'm not doing a very good job of it right now, to be honest. Env create. How does this work? Right, so here we allocate an environment off of the free list, right? We, we allocate one off of the free list. And what do we do with it? We initialize it. But I am totally blanking. I'm 1000% blanking. Because it's saying we need to search through the envs, but or maybe, wait a sec. Is it just, I need to come back here again. So here's where we allocate envs. Envs is an array. It's literally an array of environment structures. So is the idea to just literally allocate, like iterate through all of them, even the ones that are in the free list and are therefore not even active? That might be the idea. Okay. Wow. So we just need to skip over those somehow. I totally am forgetting how to, like, how we might be able to tell that. But it's probably pretty simple. It's probably in the env status. Oops. In the env. Oh, env status is going to be one of these, just basically. So we need to iterate through them in a circular fashion just after the env this CPU was last running. Okay, I'm just gonna change my camera a little bit. All right, so how do we get how do we find the end of the CPU was last running? Let's go back to, it's got to be in the, is it the per CPU state? CPU info. There we go. So I am so insanely rusty at this code, but how do I access the it's like this CPU macro, right? So I can get struct env. All right, let's just get something on paper. It's going to be something like the prev env is equal to this CPU env, right? So we access the per CPU state. We access our local copy of the environment. And now this could be prev env. This is not a totally accurate diagram, but it could point like anywhere. And we're just going to go through all of these, basically. So how do we iterate? So we basically are going to have like a current pointer, and we need to iterate through all of these things. We need to handle this wraparound kind of functionality, and and also I was just thinking about thread safety concerns, but we don't need to really care about thread safety because the global lock is going to be held. I'm going to add a comment here. Okay. is it really kernel hacking or are you developing something? I am hacking / developing a kernel. Yeah. Okay. So I'm going to need to start at the one after, but what if it's the last one also? So I think let me not worry about that case for now. I'm just going to worry about the simplest case. Let's say previous environment is the first one. So we need to start running at the second one and iterate through these. We could do that with the pointer. That would make sense. And we could just bump the pointer, and when we increment the pointer, we just need to constantly be checking, are we on the last one, in which case we need to reset it to the first one, basically. But the thing is, we want to iterate through all of them and choose the first one that's eligible, that's runnable. If we never found one and came back to the first one and it is runnable, we run that one. If we went through all of them and none of them are runnable anymore, we halt. All right, 20-second break, be right back. Interesting. So I think the general structure I'm going to try for is something like the first phase of this is going to be we're going to do an iteration through all of the environments, and that's the first phase. Second phase, if we get through all that and didn't already run something, we're then going to check the original one and see if it's still runnable, and then run that. And lastly, we're going to halt. So I think the phase, this one, try all of the ends starting from the next one. Phase 2, run the existing, and if it's runnable, then phase 3, halt. There's nothing else to do. And this is not really the best way to do this, but I'm just going to try to get something on. What am I doing? So I'm going to iterate through env -1, basically. That's the number of iterations I want to do. And I'm going to need some kind of cursor or current. But what is that? So that's going to be, it basically depends on if prevent is the last one, and so I'm going to need again, I have no idea. Like, this is probably not a good way to code this, but I'm just trying to do anything at all right now. Ends env -1 that. So if prev env equals last env, then cur is going to be envs. Otherwise, it's prev env plus 1. Something like that. Yeah. And then we're going to, so if there's 5 environments, and this is the previous one, we're going to run this 4 times. We're going to check 4 environments, which is why I did n minus 1. And so now we're going to initialize cur here, because in this case, it's not equal to last env. And then we need to increment cur env. Cur, and it's going to be very similar to this. It's going to be like, yeah, what's up, Ethiopia? Mark online, yeah, yo, great to have you. Yeah, back live. Okay, so if cur, again, it's going to be something like this. So cur, and we're just going to do cur is equal to, well, it depends. Is cur the last one? In that case, we're going to set it to the start. But otherwise, we're just going to bump it by 1. I think that sort of works. What we need to do, hey Ismail, nice to see you too. Yeah, good to be back. I'm super slow today because I kind of forgot everything about kernel development during my vacation, but we're getting there. So the whole point was just, so, all right, search through ends for a runnable environment. So if cur status equals env runnable, then it's just like, bam, that's it. That's all we need to do. And that doesn't return. That's the really tricky thing about this env run function, is it doesn't like return. Oh. Env run. Why? Interesting. Why can't I go? Oh, and it's even annotated with this attribute no return. That's kind of cool. Why can't I jump? I can't jump to, but yeah, it doesn't return. It just drops into the user space execution, basically. And basically I think that's like kind of it, actually. So we're gonna do a couple of things. We're gonna make this const. Prev, and we're gonna bring this a little bit down. So this is phase 1. Yo, hey, Neruda, what's up? I also want to start kernel hacking. Sick. Yeah, you should try it. Feel free to join the Discord too. We have a bunch of people that are interested in this stuff there, so we can chat about it more there if you want. How do I get started from the beginning? Yeah, it's a long road. Kind of depends on your current skill level. For me, following this MIT course has been good, but yeah, thanks for the resources. Oh, it's just one S. resources. But yeah, I have this list of resources. It has some books and stuff. Although I don't know if the chatbot's in here today. The chatbot seems to like only choose to work sometimes. Ah, there we go. Okay. Anyway, phase 1, try all the environments starting from the next one and execute it if we find a runnable state. If no environments are runnable, but the environment previously running is still run, it's okay to choose that one. So, phase 2, if prev-env oops. Ugh. I actually kind of wonder if that's okay, because this one will be const. So that might screw up the plan to make this. Oh wait, no, prevent is not const anyway. That's the last one. Okay, so otherwise, phase 3, halt. Current find even one runnable. Okay. So let's compile it. And it compiles, good. And let's go back here. Make sure to invoke sched yield on an MP main. Modify kern init.c to create 3. Okay, this is just, okay. I can already tell what's gonna happen. This is just not gonna work because it's like, I'm pretty sure it's going to crash Kimu again. Because we're not doing anything too different. We're ultimately just calling env run again. I am pretty confident that this is just going to crash Kimu. Whoa, what? It didn't crash Kimu? Wait a sec. Okay, something. F. Or wait. Okay, so I actually don't really understand this, but coming back to here, this crashed Kimu. This like consistently crashes Kimu. But you're telling me that somehow calling sched yield. Oh, wait a sec. I actually kind of was forgetting about the case where or at the beginning of the array if there was no previously running environment. So do I handle that case? I don't know if I really do. I mean, in that case, prev-end is going to be null, in which case it's not. So that's just not, that's going to crash. Okay, I'm gonna do this, and so if it's something, so what do I want to do? I want if it's and otherwise ends. So actually no, that's not. If it's null, we want to just, okay, I'm gonna do this. okay, what are the cases here? Prev_env can be a pointer to something, to like to something that's not at the end, something that is at the end, or it can be null. If prev_env is something that's not at the end, we just want to make cur the next one. If it is the one that's at the end, we want to make cur the first one. If it's null, we want to make cur the first one. Okay, I'm just going to, I was trying to do this all concisely and with const correctness and whatever, but I'm going to give up on that. So if prev_env equals null, then cur equals env. Or if prev_env equals null, or prev_env equals last env, cur equals ends. Otherwise, it's more like, it's kind of like else if, I guess. Otherwise, else if prev_env. I mean, is it just else actually? Oh, oops. Else cur equals prev_env plus 1. I think something like that. Yeah. So the question, like, I think the old code would have crashed. But we didn't see that happening because I think it would have only crashed on the other CPUs, which didn't have, which were the only ones that would actually have a null pointer. Cur_env also. Cur_env. So instead of the CPU env, I can do cur_env. Okay. Global variables. Okay. So yeah, now we're handling the case. If it's like a normal environment, then we just bump it to the next one. If it's a not normal one, meaning it's prev_env is null, we set it to the start. Yeah, what is the env structure? Env structure is a process, basically, and it has a bunch of stuff. I don't know what this stuff is at the bottom, but it, for example, has a status as far as the scheduler is concerned, like whether it's runnable or not. It has like an ID, and it has like a virtual memory address space, like some page tables, and it also has some saved registers. Those are mostly used in interrupt handling, I think. Yeah, it's a lot of stuff, but not all of it is important. Pretty much only the status is important. I mean, they're all used, but like the important things are like a process has its address space, it has its status, and that's kind of it. And I guess the saved registers are kind of useful. Hey Anderson, good to see you again. Drinking tea and watching. Thanks for streaming. Thanks for watching. That sounds nice. Okay. But yeah. So I am still confused though. Why? So Kimu is crashing when I do basically like the same stuff I was doing in lab 3, which is supposed to be the absolute simplest way to kind of start executing a user space process, which is directly call env run. This reliably crashes Kimu every time. There's only one CPU. Enabled interrupts 1, 2. I wonder if it's any of this like crazy. What if I just comment out all of this crazy multi-core shenanigans? Does it still crash Kimu? It shouldn't. It didn't. It also didn't really work. Received page fault from kernel mode. That's not what I was hoping for. Because like what should be happening here is it should be hitting the divide by 0. It should be entering user space, hitting the divide by 0, and then like printing that. Oh, but wait a sec. A lot of this code did change though. I kind of wish I had a better way to diff it, but I'm just going to go to GitHub. Go to lab 3. And go to trap.c. Oh, 20-second break. Yo, Russell, what's up? Be right back. So maybe that's why I'm seeing this. But I still I guess I don't know what I was kind of expecting to see. Well, it would be nice to have another checkout of the code base so I don't need to keep flipping back and forth. For the moment, I'm just going to commit basic round robin scheduler exercise 6, and I'm just gonna say temp. And let's go back to lab 3. And let's just go back to init. And we have div0 loaded in. Like this is extremely close to the to the other state of the code that we have in lab 4. I mean, you know what? Why don't I just make a copy of JAWS and go to JAWS 2. It is so useful to have 2 checkouts. Okay, so back here though. Actually, I guess I'll go into JAWS 2. I might have like paths that I messed up though. Anyway, so if I run this, what are we gonna see? We're gonna see this thing. This is what I expect. This is the expected output from running the div0 program. we load the I code, we load the process into memory, we start running it, it triggers a divide by 0, we destroy it, and we say we destroyed the only environment, nothing more? Where is that error? m.c, env destroy, nothing more to do. It's kind of like hard-coded, apparently, for that. That's what I was expecting. That is decidedly not what we see here. There, even with all this stuff commented out, and create. All right, what I'm gonna do, trust to, yes, trust the authors. So now I'm checked back out into like the old version. This is like lab 3 versus lab 4. And we're just visually comparing them. They look very similar. So I kind of thought I would have recreated some things, but a lot of this code did change though. I mean, one way I can get a bit more information about this is by diffing lab 3. Where's lab? Wow, so lab 3 and lab 4. But I want to this might not be a good way to do it, but or I might be diffing in the wrong order, but let's check out. So trap frame. I'm gonna diff well m.c, for example. Yeah. It's all my stuff, but I'm also expecting. There we go, okay. In these lines, so that's probably the reason, but I'm still a little bit startled that I'm not seeing any of this divide by 0 exception stuff being printed out here. So I just want to make sure that that's happening. And if I remember how to debug this properly, I need to do this and then continue. And that's what's making me think that we're not even executing the program properly, which is not good. Now I'm just gonna step into env run. That's what I'm gonna do. Okay. Do I get a backtrace? Yeah, I do. Get a list. Okay, yeah. Or list 1? No. Okay. But I'm definitely here. Oh, there's no current. That's unfortunate. But let's take a look. So we're running the first environment, which was hopefully successfully created by env create. Right? All we do is we allocate one and initialize it. That's it. In this case, we know that it's, what's this 0 thing? Parent ID, okay. So we know it's going to be the first one. So very easy, very simple. And so cur_env is going to be a null pointer. I'm almost certain about that. So that's why we're here. Now we set cur_env to e. E running. Runs. Switch into the virtual memory. Unlock kernel, but I never locked it. That shouldn't matter, I think. Unlock kernel. And that's where it page faulted. Interesting. So if I comment this out, what's going to happen? Are we going to see the divisor by 0, please? Cannot. Already holding. I see. Okay, in that case, I believe that message is caused from actually trying to handle the interrupt, which is a good sign though. I'm just going to do GDB and make GDB, and this time I'm going to do this. I think we're going to get here this time. Yeah, yes. And so now we're going to be able to step through. We're going to hit the divide by 0. Here, step into the trap handler. And eventually we're going to get to trap. We got to trap. And in trap, where is this thing? Trap. In trap, yeah, it tries to lock, get the kernel lock, which is not going to work. Return result. What? Okay, and okay, I need to clean this up a bit. Spin unlock. Okay, I get so confused. So in this case, we didn't lock it. We also didn't unlock it. So that's why it's totally fine to. Okay, what about this assert? That's all. Return e flags. Okay, it's all good. So now we lock. Trapped from user mode. Env, right, lock kernel, cannot acquire kernel lock already holding. Why are you saying that? Who is holding the kernel lock? I'm just going to I'm gonna add a cprintf. Yo, what's up, Dead Internet Society? Finally got to catch a stream. Hell yeah. Hell yeah. Thanks for joining. You wasn't at work. No, right on. Yeah. Thanks for joining. Nice to have you. And what's up, Pardeep Gaming? Hello. Acquiring lock. So clearly, we are doing that twice. This is annoying. Okay. Make GDB. I'm gonna break lock kernel, or was it? Yeah. I'm also gonna break. I'm gonna break on trap. I'm gonna break here. Yeah, so I think a bunch of people joined a little bit later. What I'm just trying to do is I'm trying to figure out why running this program that does a divide by 0 is not giving me the like divide by 0 exception handling messages that I expect when I run this program. All of that was totally working when I was on lab 3. And then now that I've moved on to lab 4 of the MIT class, like nothing works anymore. Or at least things are just not working the way I expect them to. So I'm trying to debug it to figure out what is going on, basically. So here I am in the trap function. Interesting that continue. Lock kernel. Into line 208, is that real? Oh, and so there was an interrupt already. Even before the idiv. Now we're going to hit trap again. Now this is for the idiv. And this thing is already locked. So the question is, who this is kind of absurd, actually. I'm going to comment out this also. I just want to see my divide by 0 message run. There we go. Now it's doing page fault from kernel mode, which I am kind of afraid of. Where do we print that again? We print that in the page fault handler, I see. But at the very least, okay, so if we remove all this locking stuff, it's actually pretty pretty concerning that we had this double lock error. Let me unwind my stack a little bit though. So I was going into this whole deep investigation for why I wasn't getting this divide by zero error. Now I see, now I finally was able to get it, but I needed to comment out this lock kernel thing. What this is indicating to me is that I might actually have a bug with the locking. I might have forgotten to So in lab 4, was it broken before in lab 3, or did you make a breaking change in lab 4? So at least with this locking stuff, that is all code that I introduced in lab 4. So it is possible that that has a bug. Here is the particular diff where I added a few lock and unlock calls. But okay, the number one suspicious thing actually is that I have a lock kernel call in the trap handling thing, but I don't have a corresponding unlock. Although I think the corresponding one would be here. Cody, what's up? The compiler settings change. Lab 4 compiling with optimization flags that removed certain checks. I don't think that should have changed. Actually, I'm running with the same compiler. I mean, that's a good point. I'll check the makefile quickly, but I sort of doubt that things have changed here. We're still running with O1, which is the typical optimization level. Yeah, no worries. Yeah, thanks for joining. Yeah, all right, quick 20-second break, be right back. All right, quick 20-second break to stand up and stretch. And let me rewind a little bit. So okay, what was going on? So basically I was commented out what's the so lock commented end run, right? So I was just trying to run divide by zero, and the locking prevented me from seeing this thing. And now there's this page fault from kernel mode. All right, but the craziest part was that Kimu didn't crash. Trap in trap. Yo, what's up, Felipe? Trap in trap. Dude, my brain is kind of fried right now, actually. I don't really know. But I mean, yeah, that's kind of, All right, I think I need to kind of do a bit of a reset. What is my working tree looking like? So I did this thing. I commented out all of this multiprocessing code. Yeah. And I was kind of expecting QEMU crash to happen. Unlock kernel. That's what I'm going to do also. I kind of want to get this temp commit back into my working tree. So, yeah. Because I kind of don't want I think I have a bit too many changes piling up here. I don't want any of this. Let me get rid of this. I'm gonna get rid of this too. So let me get things back to kind of I'm gonna take a few notes. So there are a few problems. So there was a QEMU crash if I call env run directly, but calling scheduled didn't crash, even though it just calls env run. And then I noticed this separate issue of maybe I have a locking issue and forgot an unlock somewhere. Although Felipe did mention just now that we could have a trap, we acquire the lock, and then something in there causes another trap before the lock got released, which then causes this. Yeah, like this double lock acquire thing. So it's a bunch of these different issues. I'm getting a little bit confused by it. Let me rewind even further. So here, this is going to make use of that round robin code, and if I remember correctly, this doesn't cause a QEMU crash. Oh, wait, no, so that's the QEMU crash, which is kind of what I was trying to see the whole time. Yeah, and so that's kind of what I was expecting. If we run the first environment directly, we should also see a QEMU crash. And we do, okay. Okay, I don't know what was happening there, where we kind of weren't seeing stuff, but that at least is like somewhat consistent to me. That, yeah. So that's bad. Like that's super bad. Because it means we can't make progress until we kind of figure out what to do with this. Because ultimately, there's like some problem with dropping into user space now. Okay, so at least we're able to like kind of get to this state. So we have the QEMU crash. That happens every time. That's bad. And my idea to try to understand that better was, let me comment out everything that is related to booting up the other CPUs. Let me just comment out everything related to the other CPUs. And what happens then? Save all files. What? It doesn't crash? It does not crash, right, okay. Which indicates that the craziness of like the multi-core setup is responsible for this. Oops. Let me see. So that did not crash. Right, that did not crash, but it also did not execute the divide. It seems like it did not execute the divide by 0. One thing I'm kind of curious about is this lock kernel. Actually, let me. I want to just not do anything here. I just want them to spin. What happens now? Do we crash? We do crash, okay. It's not related to this lock thing. Well, let's... Set the pick. Not the pick. Boot APs. That's not it. Well, that's so wild. Okay, let's just continue to just comment things out until it doesn't crash anymore. So that was it. Commenting out laypick init. So now I'm curious, can I add some of this stuff back? Well, boot APs is not going to work anymore. Like, this doesn't exactly make sense to do this stuff anymore if we're not doing laypick in it. Okay. Okay. So, all right, so that's a problem. The QEMU crash is a big problem. But even before that problem, it's a problem. Receive page from kernel. It's a problem that even doing this simple divide by 0 program is not working. That's also just a problem. And I want to get to the bottom of that before I move on to figuring out what to do about that QEMU thing, which is kind of concerning. And that's kind of what I was doing a little bit before. You know, at this point, it might be just a good idea to like diff, git diff upstream lab 3 and upstream lab 4. And I don't really know, like that's not the best way to view a diff. This is probably gonna be super, super long. Wait a second. Wait 1 second. Ah, okay. I thought Cody. I thought you were one of the Codys that like worked on this OS before. Okay, crazy. Yeah. If you want to rewind and watch it, that would be cool. I'm just like, this is just so deep in this crazy debugging that I'm not sure it's floating point stuff though. Well, I do want to see env.c. A bunch of stuff changed here. But also not that much. What? They get rid of the current variable, but how does that make any sense? Didn't I use that? Or is cur_env declared somewhere else now? Oh, now it's, oh, okay, now it's a macro, I see. So what about trap.c? Whoa. Okay, I'm not sure this is helpful. Okay. Yeah, it's no. I think it's hard. Like maybe it's actually hard, but I also think my brain's a little bit just like not working very clearly. I'm like not super. Like after having a few weeks off, I'm not like I'm forgetting a lot of stuff that might be important here. But also I am finding that working on such old coursework that's from 2018 has a lot of practical issues in that like the code kind of bit rots, and I spend time doing the coursework, but I also spend time trying to like fix weird problems that are a result of using like a way newer tool chain than they were using at the time, which I believe was the issue in last week in week 34. It's like a tool chain issue. Okay. But let's, I mean, I do need to get going in a little bit, but let's make a little last final effort at this. So, this is kind of where I just like I was not observing this. kernel. What I kind of feel like doing is just completely disabling all locking stuff, just for the purposes of debugging this. And that should be completely fine because I've disabled all the CPUs, all the other CPUs. What happens if I do this? Right. Okay. That causes this to work. What I don't understand is why, at least I forgot it. So why, like why did disabling all this locking stuff cause the interrupt to actually be handled when it wasn't before? Let me just rewind. Re-enable this stuff, re-observe the issue, and then debug it. Oh, okay. And I'm just gonna set all my breakpoints like a crazy person. I'm gonna break on trap. I'm gonna break on i3 to a6 init, just to really walk from very early on. Init, env init, mem check, trap init, user div 0, env run. So now we're gonna start seeing other breakpoints get hit. Trap gets hit, but the question is why? What caused that? I guess let's okay, the reason I'm asking is because I totally didn't expect, I expected oops. How do I list breakpoints again? Oh man. Alright, I'm just gonna kill the palm tree. Alright. Breakpoint list? Such a noob. How do I list breakpoints? Breakpoint list is LLDB, I think. Shit, did I set a new one? Alright, ChatGPT time. Show you how to list breakpoints. You get GDB 101. Info breakpoints. Okay, right. Yeah. Del 4. Right. Let's just step through, I guess, and just see who caused this and why. Trinity flags. Ah, so 229. It wasn't, well, yeah, it wasn't user space. It was, yeah, some kernel space thing. Page fault handler. Right, okay. As we would expect. It's just, page fault in kernel mode as a result of trying to execute this program. Which has got to be env run. Has got to be the place And didn't we see that it was the unlock kernel? I think I'm just repeating myself from earlier. Okay. So now I'm officially trying to do my thing, right? Load it. Here's where it happens, right? Yep, okay. This time I will actually take actual notes. Conditional locking with debug flags. Yeah, good idea. Okay, so, and why would that be a page fault though? To me, that doesn't make any sense. Oh, but okay, but to me, okay. I mean, yeah, it doesn't exactly make sense for me that it page faults, but I guess I can see the imbalance here. So let me try adding the lock kernel. What happens there? Sick. Okay, so now that's good. So now we actually execute the program. We hit the divide, and that's progress. We were not doing that before. It kind of, yeah. Okay. So then the question is, what happens next? So yeah, so like this is like the massive scary problem. We're not even focused on that right now. We're just focused on like the little problem. And so now what happens next? Let's debug it. Yeah. Okay. Okay. So now, I'm just gonna do all my usual stuff. Just slowly walk through it. So what happens first? So we get the weird. We get this weird trap. What is that trap? I don't think. Oh, is it? Oh, wait a second. Lock. So what has happened was we got past this lock actually. So what happened? So we, in our main, lock the kernel, execute the environment, which releases the lock. We start executing the div by zero program, but I kind of would have expected this breakpoint to get hit, but maybe, I don't know. 222. Oh. So in this case, it wasn't dying. Okay, so now we just do our typical stuff, and let's dispatch this. And it was a syscall. So now we're... What? I'm so confused. It seemed like we were in a syscall, and now we're hitting... Now we're hitting divide by 0. What was that weird syscall? Toby, nice, bro. Nice. Okay. Okay, so that was just weird. Okay. Weird syscall? Weird initial trap that runs before the idiv 0. So now we are in the trap handler for divide by 0. Search, not dying. Dispatch. IRQ offset, print trap frame. Okay. Here's where we print out the div by 0 info. $358. Where is that? Okay, now we're... Oh. Is this where we are now? No. Okay, so now we're here. Unexpected trap. Oh, I see. Yeah, so we don't handle the divide by 0. There's like nothing to handle. Although, what do I say for handle breakpoint? Nothing. Okay. So we then just go and destroy the environment, which now has some new code that did not exist last time, right? In this env destroy. So now I'm looking at the code. Well, can I jump to it? Oh, it's so cool. Or no, never mind. So this is the old code in lab 3, which just kind of like stopped. Here, they added some more code, which in particular, like, let's just see what it does. Okay. And destroy kernel caused of trap. What the? And this is probably like page fault, kernel page fault somehow, like, Jesus, okay. Why would that happen? What? So this, yeah. Destroy here causes the page fault from kernel error. And that is interesting. What is that all about? We can continue stepping. I can almost guarantee you that it's going to be a page fault exception. From kernel mode, yeah. That's interesting. And not really sure what to do with that, but I think it's something about accessing this kernel somehow. But I'm actually kind of even losing, like, what does page fault from kernel mode mean? That means we're executing kernel code. Like, obviously it means we're executing kernel code and a page fault happened, but what does that mean the kernel did? Does that mean the kernel accessed, like, out of bounds memory or something like that? I'm kind of, what's the page fault again? Yeah, there's like all these conditions. It's like when the kernel accesses a page that's not present, like memory that's not marked present in the page tables or something like that. But I don't know, like, 'cause that indicates some kind of virtual memory issue or something. But one thing I can do is just current env, because current env is now this like macro thing. Oh, wait a sec. Maybe it's related to the fact that I commented out all of the multiprocessor init support. So CPU num is probably going to return 0. But CPUs should still exist, so let's try. Okay. So I'm expecting 3 traps. There's like this weird first one. There's the second one for divide by 0 by 0, right? Flags. Yep. Okay, here we are, 361, right? Does this cause it? No. Step into env destroy. Does this cause it? Yeah, it's the env free within. Oops. What does env free do? All this stuff. Wow. All right, this might be one of the last things I do today, but let's just let's have eval exec. This might be one of the last things I do today, but let's just see. That did it. This like C printf. Oh. Yeah, I don't know, maybe. But maybe like all this, like maybe this is somehow related to the fact that I'm commenting out quite a bit of code in order to not cause the Kimu crash. But what's like, how could this? All of this is just like mapped memory. Like it should just be totally valid to access all of these things. I don't understand why that would do it. So let's just drill down into it. Okay, so I'm going to do x equals, I don't really know what, this is just env ID and something, oh wait, no, cur env ID and cur env and free. I don't know. I don't really expect that accessing these variables is causing it. It might be something within cprintf, which would be awful, but let's just try. No, that was it? Accessing env ID caused it. What is e? And it's the thing passed in. Whoa. Oh, is it null? Cert e. Is it? I don't think is it. There's no, it's a null pointer, is it? It's a null pointer. That's why. We're freeing a null environment. That's why. And how is that possible again? We're calling mdestroy. On cur env, and it comes from here. I'm just gonna, yeah, assert cur, right? Yeah. Okay, we're freeing. Oh wait, what? Okay, I am actually getting kind of confused. How? Wait, what? Right? Wait, what? Am I just like overlooking something extremely obvious? Like, wait a second. Okay, this is happening from somewhere. Wait a sec. That is extremely odd that those other asserts that I just added are not firing. Shouldn't, like, if we're passing a null pointer into this function and it's asserting right here, shouldn't this one, is n free called anywhere else? I am so confused. Assert kernel. No, this makes no sense. I must be doing something stupid. This makes no sense. Assertion field E. Oh, wait, yeah. So... yeah, Cody, I'm not working with Linux at all right now. So I do not have dynamic kernel tracing at all. Yeah, this is my own kernel. Well, it's technically this like MIT course kernel. But now this is very interesting because what I want to do is en free, continue. So wait, what? E clearly has a value. Am I being like dumb? Like, what? What just happened? Didn't E very obviously have a pointer value? What? Did I assert that? What? Is this how you... What? How is this possible? Alright, one more time. Oops. Right. E is optimized out. Of course E is optimized out. Oh, what? What to do? So, I mean, very, like, it's clearly stating that E has a value. That's not a null pointer. A second and free. Do you mean maybe that it's called a second time with a null pointer, Felipe? Wouldn't my breakpoint hit? I have this breakpoint on end free. What is going on? How is it? So I can't print out the value of E. I mean, actually, I literally can actually, not in the debugger, but what am I doing? Okay. Just add an 888 just so I can see it more clearly. What is going on? Okay, well, that looks like 0 to me. I don't know why. Okay, the debugger must have just been like lying, basically. But and destroy, right? So I also have this thing here, right? Like, why is this assert not failing, but this one is? And maybe Felipe, it's your idea. Maybe it's because there's like these different calls. Dude. What? Here's what we are seeing. We are seeing end of destroy E. It's like this like pointer. Do I like... We set this thing to null. What? End destroy E. And then we go into end free. And it has suddenly become null. Ah, very sharp, Cody. Wait, is the current pager switch correct? I mean, you are totally right, actually. Well, do we execute this? I guess we... do we? Yes. Right, we do execute this. But what the... But wait a sec. Wait a sec. Let's slow down a little bit. Wait. E is a variable passed... We're not dereferencing E in this print. We're not really accessing memory, per se. If freeing the current, switch to current page before freeing the page directory, just in case the pages were used. Switch to current page directory before freeing the page directory. Switch to current page before freeing the page directory. So we free the page directory. What does that even mean? Yes, we definitely do not want to be running on the current page directory as we're freeing it, right? So, but but running in the kernel anyway, so oh wait. Yeah, so we're running in the context of a process or an environment, which means, and since the kernel should be mapped in to every process, that's okay. We can still run within the environment's page directory. And so it's actually fine that we haven't done this yet. I guess it's probably something with that. I don't know. I'm just gonna do it in assert 0, and I'm gonna comment this out just to see if that reveals some more information about this. So yeah, Cody is right. If we comment out that switch CR3 thing, then these things are actually the same. But for some reason, this CR3 swap causes E to become a null pointer or something like that. Okay, time to take some notes. And oops. Something like that. All right, so what do we know? So if we comment out the LCR3, that causes the E pointer to no longer magically transform into a null pointer. It retains its value from the env destroy caller. Oh man, there's so much to scroll through. What? I'm just trying to find this thing. However, if we keep the LCR3 as it should be, then E turns into a null pointer somehow. Yo, what's up, Narrow? I am on an ARM Mac, yes. I am going to just print this before for LCR3 after LCR3. Let's just take a look. Okay, wait, what? What? Why? Wait a sec. What? Why? Why are these all the same now? We have the LCR3 in there, which is the thing that should be causing the magical transformation to a null pointer. But what? If I remove this, what? I'm so confused. What? Why? What? I'm so confused. What? Wait a sec. This is... Wait, what? So if I add the assert 0, does that influence this? Holy crap, I think it... Wait. Am I... The only thing I'm changing is commenting out this assert 0. So if I have the assert 0, then they are the same, right? The LCR3 is there the entire time. Watch out, could be some compiler optimization. It might be. Oh, oh wow. Dude, it might be. So we have the 0 in there, and the E, everything is behaving as normal. But if we remove the assert 0, it becomes a 0 and fails the assertion. Oh my gosh. Dude, I totally would disable optimizations, but I can't because the kernel doesn't boot if I do that. That's been like a very, very long-standing problem that I've just never debugged. I don't know why. If I disable optimizations on the kernel down to 0, the kernel just doesn't boot. And so that's super annoying. But this is really the craziest thing. Mark E as volatile. Can you do that for an argument? Okay, well, guys, I gotta go. I am so confused and I don't know what to do, but like, this is crazy. Let me see if I can just recap. So today, just to recap, I was trying to work on Lab 4 round robin scheduling, but what I discovered was the code for Lab 4 seems to have like changed a bunch of stuff, and yeah, I think I'll have to do this all next time, guys. Or what is current env ID val? Let's take a quick look. All right, last thing we do. Give me this thing. All right. Well, current env? I don't even know. I don't know what current env. I don't have no idea if that's a null pointer or what. X1000, not sure. Yeah, I gotta get going, guys. Yeah, I tried doing this thing, but then what I found is that there were a bunch of issues running the kernel. For one thing, there were QEMU crashes. QEMU started to crash if I just started to like do my basic tests of running like a process, but with all the new code that added multi-core bring up, the simple code for running like a divide by zero program crashed QEMU. So that is wild. So then I figured out that if I disable and comment out like all of this multi-core bring up stuff, the QEMU crash does not happen anymore, but the code still does not behave like it should. It was, instead of doing the div by 0 printout thing, it was triggering this kernel page fault issue. But then I think I kind of fixed that by adding this lock kernel right before here. But even still, there remains this problem where after it handles the divide by 0, the kernel basically blue screens with a kernel panic because of the page fault from kernel space. And we've been trying to debug that, and y'all have been extremely helpful, and I don't know what's going on. It's like something happens here where where basically there's a kernel null pointer dereference, but to me it's extremely unclear why the pointer, like the cause of the null pointer dereference, because the caller of envfreep does not pass a null pointer, but something happened, the caller does not pass a null pointer, but something happens here that causes a null pointer dereference under certain circumstances, and it seems like whether I have this assert 0 in there, that seems to affect it, and there is potentially some cause of like maybe some relation to this load CR3. Maybe this is cprintf. I have no idea, and we'll pick up with it next week. So thanks a lot for all your help, guys. Thanks a lot for tuning in. What's up, vpool? Nice to see you. I'm going to sign off, and I'll see you next week. Like, comment, and subscribe. Join the Discord if you want. And yeah, have a nice week. I'll see you next time. Peace. Cheers.